Right now we're going to look into the sum and difference rules for taking derivatives. So essentially this is going to work as it does in algebra, where if we have the sum of different functions, we can take the derivatives individually and add those derivatives up. So in a similar fashion, if they're being subtracted, so derivative of two different functions is just the derivative of the first function plus the derivative of the second function, and if there's a third, and so on and so forth. If we're taking a difference of two, if it's the derivative of one function f minus function g, it would be the derivative of function f minus the derivative of function g. The last thing I talked about is the constant. You can take the constant out. You just pull it right out of the function, and that works. It's the same sort of thing. Think of it as a scalar for matrices. So if you take the derivative of some constant k times a function, you can pull the k out and multiply that by the derivative. All right, so here's two examples from the suggested homework. We're trying to find f prime of x, which again is a derivative. I'm going to do 109 first. I've got 112 on the left for a different reason. All right, so 109, we want f, sorry about that, f prime of x. So basically we can take, think of that as g, h, and I, three different functions. So this is going to equal the derivative of 8x to the fourth plus the derivative of 9x squared minus the derivative of 1. With this first one, we can pull out that constant. The second one, we can pull out that other constant, 9 this time. And I'm going to take the derivative of this thing is equal to 0. Where derivative of constant is just 0, so, minus 0, if you will. But that doesn't matter. Now, with this part, we're going to do the power rule. So 8 times the derivative of x to the fourth, the 4 comes down, x to the 4 minus 1. And then we take 9 and multiply 2, x squared gives us 2x to the 2 minus 1, which we can now multiply 8 times 4, so we have 32. 4 minus 1 is 3, so x cubed. And this is 18x. Now, you don't have to show all of that work like that if you don't want to. This number 109 can be literally done in one line. I don't need to see the work. You can multiply the 4 by 8 and get yourself 32, and 4 minus 1 is 3, and so forth. Literally, you can go from this step to this step without much of an issue. Now, some of the later ones I'm going to need more work for. Number 112, based upon what we have here, we have two functions, but they're not being added, they're being multiplied. I'm just going to FOIL this out for now. We're going to do this problem again after I show you a different rule, but let's just do it with the rules we have now. Excuse me, I don't want to take the derivative yet, so I'm getting rid of that. It's just f of x, and I'm going to do FOIL. So I've got 2x cubed. Outside would be, we're looking at minus 6 plus 4x squared. Oh, excuse me. X, that's negative 3x. It's 4x squared, and then the last would be minus 6 that I was trying to do earlier. Okay, we can reorder this, but it doesn't really matter. I'm going to take the derivative now of each individually. So this one is 6x squared. 3 times 2 is 6. 3 minus 1 in the exponent is 2. This one, the exponent's 1, so negative 3 times 1 is negative 3, and 1 minus 1 is 0, so it's just x to the 0, so I leave that alone. The next one, 4 times 2 is 8, that's 8x, and this last one, this is 0. That goes to 0 as a derivative. If you want, I can reorder this now. What do we have? 6x squared plus 8x minus 3.